guys, we're gonna do test corrections. Okay, so if you could write the word test correction here, that will help us, okay, because when we have a lot of tests floating around, and they all look the same, right? A lot of them look the same. So this is the test correction for Form B. Now this got a little weird, so let me just clarify. It says, but I told the rest of the class, it says map this onto this, map EFGH onto the dash. But then when it was dash, you couldn't see it, so I highlighted this big. Then in the middle of the test, some kids were like, which one should I move? So I said, move this one onto there. So I think I counted it right if you got A or C, but technically, I don't think either A or C is right. So anyway, let me explain. If this is your pre-image, let's add this to the picture and I'll make sure that it's right on the retest. This would be E, F, G, and H, and it would be labeled on the pretest, okay? So this is our pre-image, and our image should have little primes on it. Okay, so if this really is our pre-image, and that's what I told everyone in class, the bold one is before they did the transformation and the lighter one is after. Okay, if that's true, then it definitely got smaller by a ratio of 1/2. So it definitely got smaller, and you could look, this is coordinate 2, 2. So point E is coordinate 2, 2. So it got smaller by 1/2. So if we multiply each one by 1/2, we get E prime is 1, 1. So this would be, if we dilated it at the origin, so if we think of it, between the origin and E, halfway in between would be there, and between the origin and H, right, halfway would be here, and between E and F, halfway would be here, and between E and G, or excuse me, G, halfway would be right about here, okay? So this would be my new shape if I cut it in half. This would be my new shape if I dilated it from the origin. So here it is. Now, it's not laying on top of this, so I need to move E prime, and I guess this would be a double prime then. I have to move it once and then move it one more time. I need to get it up to 1, 5. So if E double prime is up at 1, 5, and oops, sorry, I made a mistake. E is at +2, -2. So +2, -2. So this would be E prime is at +1, -1. Yep. Okay. So how would I do? So notice nothing changed in my X. Nothing changed. It just stayed the same. What changed here? It needs to go up 6. So this should have said up 6. Okay. So technically that should have said plus, and A would be the answer. I also took C because notice it got half as big. So if you got half as big, but you weren't sure how much it moved, so sorry about my mistake. I'll definitely make it up. Now it didn't get twice as big, so that's why you should have eliminated B and D. Okay, next question. The scale drawing of the solar system is 1 millimeter is equal to 500 kilometers. So this is similar to 1 foot is equal to 12 inches. So this is a ratio that you have to multiply by whatever you have. So you have a 8,500 kilometer diameter, and you want your answer to be in millimeters based on the drawing. So I want my final answer to be in millimeters, so I need this kilometer to cancel. So I need to set up the ratio that this part is on the bottom, 500 kilometers is on the bottom, and the 1 millimeter is on top. Why? Because I need this to cancel, so my answer is in millimeters. Okay? So I'm going to divide, and I get the answer . 6 17 millimeters. Okay. Now, what's next? ABC has the vertex. So ABC has these vertexes. Okay. And what are the new coordinates for A when the triangle is translated to the left? Okay, so let's translate this thing to the left. Right, so to the left, if I think about my coordinate plane, when I go to the right, or I go to the left, up or down. When I go left, I go into, oops, sorry, you didn't see that, up, down, right, left. When I go to the left, I go into the x direction, negative. So I'm going to subtract 4 from all the x values. So 0 minus 4 is negative 4. 0 doesn't change because I just moved left. 5 minus 4. The y doesn't change when I move left. Only the x values change. And there we go. Now you could also graph this and move the whole triangle to the left, and then you'd notice, or you'd read off your coordinates. Now what else do I have to do? Well, there's another thing I'm supposed to do, a scale factor of 2. So that is every coordinate, when I make something twice as big, it doubles in size in the x direction and the y direction. So my final answer, I have to multiply negative 4 times 2 is negative 8. 0 times any number is 0. A lot of people got that one wrong. 1 times 2. Negative 2 times 14. Okay, so there is my answer. This is the new coordinate if I shifted it to the left and doubled the size. Okay, so they've set this problem up and they've said solve for the pole. Okay, so are these two triangles similar? Yeah, because of angle-angle similarity. The mirror creates the same angle going up when I look at the image as going down. So let's take the small triangle and order them least to greatest. So the two sides, not the hypotenuse, but the two sides are 3 and 7. And when I look at the bigger triangle, the two sides in order least to greatest are the 9 and the x. Okay, so we're going to cross multiply and solve. 3 times x is equal to 9 times 7.7. So 9 times 7.7 is 69.3, and we still need to divide by 3. Okay, so we divide by 3 on both sides, and we get x is equal to 23.1. Okay, so is this the same question or different? I actually think it's pretty much the same. So you could have used the picture over here. A building is 68 feet high and it casts a shadow. Ooh, that's longer. So it must be the sun is pretty low in the sky. So the shadows live on the ground. The shadow is 276. Okay, Sarah. So I don't know where Sarah is standing, but Sarah is over here. Sarah says, we don't know how tall she is, so we have to make x what we don't know. And her shadow is 16 feet long. Right? So let's order the sides least to greatest. If the sun is in the sky at this angle, that's the same angle, the angle of the sun, then this should be the longer side and this should be the longer side. She is not 16 feet high. So let's set up the ratio. So ordering the small one, least to greatest, x and 16. I know the small leg and the medium leg, and small, medium here. Now let's cross multiply to solve. So 276 times x is equal to 68 times 16. 68 times 16 is 1088. So let's divide. We get 3.9. Oh, it said round to the nearest foot. So I'd round that up to 4 4 feet, even. Round to the nearest even foot. Okay. Next one. Are these two similar? So let's look at the information given. It looks like the small side, these kind of might look the same side, but the small side is 9, okay, and the medium side is 18, and you're not sure, but between this angle, 76. And now the small side for this one, right, is 21, and it is on the other side of this angle, 42. So if these sides make the same decimal or the same ratio, are they the same ratio? That's really the question. If they are, and if the angle between those two sides is equal, well, that we do have that. We have 76 degrees between these two sides. So let's see if they make the same ratio. 9 divided by 21, 0.4286, and it keeps going. 18 divided by 42. Ooh, and it is the same ratio. Then yes, the triangle is congruent because of side angle, side similarity. Are we done? No, because it said state if they are similar and state the theorem, that's the similarity theorem, and then complete the similarity statement. So we have to name it, and they already named the mom, the bigger triangle, FGH. So angle F is 76, so we have to make sure we use the letter U because it is also 76, okay? Now let's find the next corresponding side. So they named it FG, so that's the longer side, right? So we have to start at the 76 and go across the longer side. So we have to name that UV. So UV is the corresponding side. So I have to use the letter V. And then last, they went across the smaller side. No, they didn't. GH. So GH is the side that we don't have information about, so we have to pick this side, VW. Okay, so that is the similarity statement. And yes, the order matters because they picked the order here, so we have to mimic the same order.